my name is Jody Schollard. I'm the Southeast U.S. Sales Manager for Chicago White Metal. I've been in die casting industry about 9 years, just over 9 years, after escaping after 8 years of work in the automotive industry. And I have an engineering degree from Auburn. So anybody who cares to make any references to our bad football season this year, please go ahead. That's another great side effect of being muted on your end. I can't hear that either, so please help yourself. On the line as well and answering questions will be John Miller, Mike Dimitrov, and Tom Rock. So we definitely encourage you to ask questions throughout the webinar. And I know you're saying, well, if I'm muted, how am I going to ask questions? So what you do is on the control panel for the webinar, there's a box and a section for questions. So just type in your question in the box, hit send, and we will do our best to answer it as we go through. The seminar or the webinar today will be about a half an hour, maybe plus or minus a few minutes, and then we'll keep the webinar open longer than that. So if you have any questions that you can't get to or don't want to ask during the presentation, you want to ask later, we'll keep it open for questions. If at some point you have other questions in the future that you'd like to ask, my contact information is at the end, and we will be sending that out to you. And feel free to contact me directly. So the agenda for today's webinar: why, when, and how of conversion from machining to die casting. That will be the main focus for today. We'll look at conversion case studies that we've done in the past as a company, converting other customers' projects from a CNC machined part over to a die casting. We'll look at some design considerations to take into account. When you do change from CNC to die cast, there's obviously some things that are going to be needed to be done differently from a design standpoint. We'll look at a few of those. We'll talk about some of the alloy options available for die casting and the ways to compare that to the CNC alloys that are out there. We'll look at some prototyping options for die casting, as well as some finishing options. So why should somebody convert from a CNC part to a die cast? It really comes down to money. The biggest reason is to try to save on a part price. What typically happens, and what we've seen many times in the past, a customer will come to us. They have a new project that was started maybe a year ago, a couple years ago. At the time, maybe they needed 10, 20, 50, 100 parts at one time, and it didn't make sense to do it as a die casting initially. So rightfully so, you start with a CNC or a machined part as a way to produce it. And then a year from now, or a year from when it started, a couple years, you look up and you're buying 500, maybe 1,000, and start getting into higher volume quantities, and you realize I'm spending a ton of money on a CNC part. The guy that owns the CNC shop just picked me up yesterday for lunch in his new Bentley. I think maybe we should look for a better cost-effective way to produce it. So die casting is a great option, and that's what we're going to talk about. Reduced part delivery lead time. Die cast process runs very quickly once the part is tooled and in production. You can definitely cut down on your lead times. Part-to-part consistency. Again, once the part is hard tooled and in production, you will get very repeatable parts coming out of the tool. Optimized part features. One of the things we talk about here coming up, and one of the big advantages, is being able to optimize what gets put into the hard tooling. You want to take advantage of as much as you can ahead of time, get as many features, get as many advantages for you as you can ahead of actually tooling up a die casting. So definitely consider what all you want and what makes sense for your project. Reduce weight. Again, in a hard tool die cast part, you can add what's called weight savers, where weight in certain areas that's not needed, you can take out by putting a feature in a tool, and that would be a big benefit. Reduced number of components, another good one. We have a couple of case studies coming up that will show you where we were able to take a part that had a 5 or 6 piece assembly that had a machine part and or 5 or 6 machine parts that were welded together, and you can convert that to a single die casting. So you can imagine the cost save for doing that. And the last item is environmental benefits. So because of on a CNC part, typically there's a lot of waste. Some of that material may not be able to be recycled. Die casting eliminates most of that waste and is 100% recyclable. So when should you convert? First tick item is when design is stable. So if you've been in production for a couple of years, you realize my part is not really changing. It's been very, very stable. The project is stable. It's a great time to look at converting. If there's still things in flux, the part changes every now and then, maybe it's not a great time to convert yet. When volume has increased or is expected to increase, again, that's the biggest reason to do this, is if the volumes are there to justify paying for a die-cast tool and can save money. As I mentioned, when multiple parts can be converted into one single die casting, and when there's enough project life remaining that it makes sense. If the project's going to end 3 months from now, then it probably doesn't make sense to convert to a die casting. When should I not convert? Volume is just too low to justify the die cast tooling payback. We'll look at a kind of economic example here in a minute. You can kind of see how it's not rocket science. You can see where the break-even points are and how long the tool payback period is. And if it doesn't make sense, it doesn't make sense. Again, design is not stable. That's another factor. If the die-cast alloy is not suitable for the application, there are definitely differences between most of the alloys that are used for CNC or hog outs versus what you'll see as a die casting. We'll provide you with the material specifications for the most common die-cast alloys. It's easy enough to compare the various characteristics you're looking for to see if it makes sense to convert. If dimensional tolerances are too tight, if the product, after it comes out of a die-cast mold, still needs to be machined a great amount because of the tight tolerances you may have on your part, well, maybe the payback is not going to be as quick, and economically it doesn't make sense. So that's another factor. And the porosity issue. All die castings have some amount of internal porosity. If for some reason your application requires zero porosity, then maybe conversion to die casting is not the right way. So how do I convert? Obviously, as the die caster, we would like to get involved as early as we can in a project and go through all the aspects of what you need, when you need it, the different features that the part will see in its life, and help you as much as we can early on. We have a number of design guides that are also located on our website in the Design Center that will help start the process of how to convert from a CNC part to a die cast. All the alloy information and that type of thing are on our website. Our sales and engineering group is very ready and able to help if you want to send us a model or a concept and talk over either live in person or on a go-to meeting such as this. We can look at the project and give our input to you real time. And in fact, our engineers at our facility can take a 3D file and do the conversion for you. There's a number of things that are going to need to be done to a model for a CNC part that will need to be done for conversion. We're more than willing and capable of doing those changes for you. The Chicago White Metal uses another tool called the MagnaSoft Flow Simulation that also aids with our design. And lastly, have confidence. Chicago White Metal has been in business for just over 75 years, have done many conversion type projects, and we have confidence we can help you too. So let's look at a few conversion examples that we've had in the past. What you see on your screen is a ruggedized computer chassis, if you will, that was converted from a 6061 aluminum to 380 aluminum. The picture on the left is obviously the CNC version. The part price was in the $220 range. This is a fairly large part, so it's probably 10 by 12 and then 2 or 3 inches deep. So you can see it's a pretty big part, a lot of wasted material when you machine out that much depth. And the project volume was in the 1,000 piece per year range. So converting to the die cast, it was converted to a die cast aluminum 380 alloy. Part price dropped to around 20 bucks. So you can see a $200 part price savings from the CNC to the die cast. And that gave over 1,000 pieces, that gives you about a $200,000 annual savings. So assuming the tooling was probably in the $100,000 range for a part this size, tooling payback was about 6 months. So you can see for this application, it does not take that many pieces to really justify a tool and start seeing your cost savings. This next example is what I alluded to earlier about taking multiple part assembly down to a single die casting. The picture on your right is the final product, but you can imagine all the threaded features that are on here were individual screw machine brass parts that were welded or somehow assembled to an aluminum body. So when our customer came to us and we started talking, we said, well, hey, you could potentially make this as a single piece part. We decided to do a Zamac alloy for this application for strength and other reasons, and we're able to do it as a one part. All the OD threads that are on this part is as cast, so it's already in the tool. There's no post-machining required, and we were able to get a huge cost savings for this customer. This next example, I mentioned the miniature zinc die casting process, and that's what was utilized for this. These were small, very small screw machine brass parts that were converted to a zinc die casting. And you can see the individual part pricing savings was significant as a percentage of what the CNC or what the screw machine version was, but not a huge amount per part. So you're talking 12, 16 cents for each individual part. So this type of project would obviously need a higher volume to make it make justification for tooling it up. But usually small parts like this will have a higher volume. So in this case, we were able to save about $85,000 a year for this customer once these two parts were converted. And lastly, this is a microwave splitter part that, again, you can see as is a very low volume requirement, but very difficult to CNC machine. Some very tight tolerance features, and converting over to a die casting was a huge cost save. So let's look at some design considerations. As I mentioned, converting from CNC to die cast, you're going to have to do some things a little bit different. And you saw on maybe that first case study, that big chassis part, some of the overall features that would have to change. We didn't focus on it much there, but we'll look at some of the individual features here. So relatively consistent wall thicknesses is a thing to consider when looking at die casting. Die castings don't have to have 100% consistent wall thickness around the part, but it definitely is a help when thinking about how the metal will flow in a part and how the part comes out of the tool. Eliminate undercuts. We'll show that in a minute, where some features that you can easily machine in, if it creates an undercut with the way that the tool forms a cavity or a certain feature, that's a problem. So care needs to be taken to eliminate those as much as we can. Add draft, ribbing, radii, and weight savers. Again, things we've talked about to some extent, but we'll show examples of. So the first one, the consistent wall thickness, you can see on the picture on the left has at the very end that's circled a section that has a pretty thick area and is inconsistent with the rest of the part. The rest of the part is all cavitied out, has some ribs that are there in place of material. So on the right, we were able to take away the majority of the mass in that area and put a rib through the middle and keep the strength that's required there and take away a significant amount of mass. So the things that improves, the better metal flow through that area. You can imagine as liquid metal flows through that section, instead of having to fill a large, thick, solid area and taking longer to cool that area, it's now flowing similar to the rest of the part and in the same type of wall sections. The reduced amount of weight means added cost savings, just that less of material cost that goes into the part. The cycle time is improved, again, because there's less mass. Cycle time, you can speed up your cycle, that type of thing, and less chance for porosity. The big thick sections do tend to give the better chance of internal porosity in those areas, and if you can minimize those, then you minimize porosity. The undercuts that I mentioned, here you can see on the left two views, left and center view, that is the previous machined version of a part, and there was a section in there that had a bit of a recess that was cut into the part. And if you can think about how a die-cast die is going to come down and form the center diameter of that part, there is no way for it to create that undercut feature because it'll impact and not be able to, you won't be able to get the tool back out. So one of the things we had to consider was, okay, how do we remove that, still keep the functionality of the part, but have straight wall sections that are going down through the through those walls and eliminate that undercut. So that's another thing to consider if you have that a feature like that on your CNC part. If it's the bottom bullet point, if it's something that has to remain as a part of the functionality of the part, then we'll have to go back in as a secondary process and machine that that groove or undercut feature back in. And obviously, the more you touch the part after it comes out of the die-cast die, then that reduces the cost-saving benefits that you're seeing. Add draft. That's a very common thing for die casting. Pretty much every die casting requires it. The left view is just a very simple depiction of theoretically a CNC part that has very straight walls all the way down. And if you think about again how a tool how a tool section has to come in, form that feature, and then the tool has to open back up and allow the part to eject out. It's very difficult to do that if there's no draft in there. So on the on the right view, you can see that the walls have been tapered in so that the tool has an easier time removing itself from the part, and the part can be ejected. Ribbing is very important. It's a great advantage to be able to add ribs to various sections of a die casting. Here are two examples where you can see ribs were added in several different areas. Both parts you were able to remove potentially a large mass area and instead have ribs going through that area where the mass was. And it increases the overall strength of the part, helps the liquid metal flow better once it's as it's being die cast, and obviously it removes a good bit of mass. And again, if you can take the mass out, it improves your cost savings ability. Add radii. This is a little bit hard to see, but we blew up a couple of areas on the part. You can see on the part on the left, that's a CNC version of a part, and it's got very nice sharp edges on the features, which is what you would want to do as a CNC part. As a die casting, if you think about how liquid metal flows and creates a part, it doesn't like sharp corners. It just metal does not flow very well over sharp areas. So we will request and work with you to try to put as much radii and fillet area as we can in certain features, just so that the metal flows better. It also reduces some of the high stress areas that might be present if you have sharp edges remaining. Adding weight savers is another great tool. And again, when you're converting over to die casting, you want to get as much bang for your buck as you can. So these are all things that will help you think about as you're converting from your part over to a die casting. The left view is the original part, and you can see the big area in the center has a very thick section of metal that's really not doing anything. There's no reason for it to be there. So if it doesn't need to be there, let's try to remove it. So all you do is on the right view, you can see a feature was built on inside the die-cast die that cores out that section of material, and it removes it, and you're getting less weight, improved cycle time, again, the porosity reduction that you get, and it's all good things. So just another thing to keep in mind, we want to try to get as much mass out of a part as we can. So looking at some alloy options that are available, this chart we will send to you following the webinar, so I don't have to take notes or anything. And this is this chart is Chicago white metal specific. So this gives you the alloy types that we use as die casting. So the first column is the aluminum alloy we die cast with, which is 380 aluminum. The magnesium we use is AZ91D. And we have two zinc alloys, Zamac or zinc number 3, and then a ZA8, which is a 8% aluminum high-strength alloy. Again, the part size range that are listed, as well as the machine tonnage, that is all specific to us. So it gives you an indication of the type of machines that we have, the size that can be achieved with the various alloys that if you come to Chicago White Metal, that's what we can do. So just keep that in mind. Some of this is Chicago White Metal specific, but it does give a good overall representation of what we can do for you. And there's another chart that will be going, I don't have it in here, of the material specifications. So you can see exactly how 380 aluminum compares to 6061 or other types of the typical billet material and alloys that you'll use in a CNC. So you can see exactly how the strengths compare and the various physical properties you're trying to achieve. So for prototype options, there are a number of prototype options to look at for die castings. The first one is a single cavity hard tool. So it would be basically the same H13 steel, tool steel that we use in the normal production tool. We can do maybe a single cavity version of that to get you a very real life prototype. Some projects require the exact type of part that you're going to be making in production to prototype and test with, so that's an option. Another option is doing a single cavity soft tool. So we would potentially, depending on the type of part and size and that type of thing, be able to offer a P20 or other type of less hard, I guess, if you will, tool steel to create a die and run a limited number of parts off of. It won't get you thousands of parts, but it will get you enough to have a very good representation of what will be done in production and be able to test with and that type of thing. Rubber plaster molding is another great option for prototyping these type of parts. Not something Chicago White Metal does in-house, but we have a number of partners that we recommend to look at for doing this process. It's similar to an investment casting, but it's relatively low tooling expense, a little bit higher part price than what you'll see from a production part as a die cast, but it's a great option for getting very close representation of how the part will physically be and materially be in production. FDM, or a fused deposition model, is a great option for maybe one or two parts if you just want to have something to touch and feel and see what the features look like and that type of thing. That's a great option for that. We have that internally at our place, as well as some of the other vendors that we recommend for prototyping have that as well. Sandcasting, you can do some sandcasting prototyping of the parts. And then lastly, machining hog out. It sounds a little weird to why would you machine a hog out if you're trying to get away from that, but you could machine the exact type of features that you're going to see that you have to change to when going to a die casting. You can machine another part to represent that. The alloys would not be the same, but you could at least see, and you could machine in draft. You could machine in all the same features that you will have to utilize as when you go to a die casting. The post-casting operations, I'm not going to focus a lot on these. This was a big topic of the second webinar we did, so I invite you to go back and revisit that on our website if you'd like to, as well as we have a number of handouts and guides and that type of thing on our website as well that you can research the various options for postcasting. But needless to say, there's a number of things to be done that can be done after the part is physically die-cast. You can do deburring, again, additional machining if there are tolerances or features that are not able to be die-cast in. A number of dozens and dozens, actually, of coating and platings and wet and powder coat painting, that type of thing, as well as graphics from pad printing or silk screening can be added. Mechanical assembly, if there's a number of mechanical components that make sense to come in to you as a part of the die casting or with the die casting, we can do that for you. And again, there's a number of guides on our DC2 section of our website to review. So lastly, again, there'll be some additional information coming your way for some of the tables and graphs that we showed in this presentation, as well as some other technical data sheets will be emailed to you following the presentation. We'll also have a survey coming, so if you would take a minute and fill out the survey, it'll let you have some input on how this webinar was, as well as future webinars if you have an interest in something else, maybe past, further along down the line after the Miniatures Inc. diecast webinar that we're going to put forth in February. If you have other topics you'd like for us to cover, please definitely mention that. And again, please visit our Chicago White Metal Design Center for additional information. And I want to thank you again for joining us. That's the end of the presentation. Again, we will keep the online version of this going, so if you have additional questions, we'll still be here to answer and definitely help you any way we can. Here's my information. This will also be coming out in an email, so you have it if you want to write it down now or wait till the email comes out. But if you have anything specific you'd like to talk about that you weren't able to or didn't want to try to get questions answered through the webinar, please don't hesitate to contact me, and I will help you out as best I can. So thank you very much, and I look forward to working with you on a diecast conversion project.